Stub in OSPF. There were 4 types of stub in Cisco. In industry standard, there is only 2 types. One is simply stub. The other one is not so stubby area. These two are industry standard. What does this do? This blocks LSA type 4 and LSA type 5 entering. It denies LSA type 4 and 5 entering into a router, into an area. Then how you will reach those type 5 networks? What is type 5 networks? External networks. The redistributed, the one which is coming from other routing protocol, the other source, not from EIGRP. Sorry, not from the local OSPF. See, there may be another OSPF autonomous system. From that autonomous system, you are redistributing into this autonomous system. That is also considered as type 5. Even though both are OSPF, it is not same autonomous system. What determines an autonomous system in OSPF? One area 0 in the middle. If you have 2 different area 0 in the middle, then it is 2 different autonomous systems. So you may have one router with a membership, 2 autonomous system membership. Resume now. So let me quickly repeat because I didn't record. I'm going to quickly repeat what I was telling. So you've got area 1, area 0, area 0. It's not one OSPF. It is 2 different OSPF. It's 2 different OSPF running on this router. OSPF 2 is what in green autonomous system. OSPF 1 is what the member of brown autonomous system. So if you expect ping from area 2 of brown to a network in any area of green, you need route. For that, we redistribute from green to brown and brown to green. Yes, you have to do redistribution. Though it is OSPF, it is not going to get distributed because it is of different autonomous system. So when I receive the route alpha from green on this router in area 2 brown, I'll receive as type 5. And now when you make area 2 as a stub area, type 5 and 4 is denied. What you receive is a default route from area 2's ABR. Yeah. So using the default route, you will be able to ping alpha. This we have already seen. The next stub type, which is industry standard, is not so stubby area. What it is going to deny type 5 LSA as well as type 4 but in that NSSA area, if you will have an ASBR, in that NSSA area, if you will have an ASBR, those routes will appear in the routing table as N, not as E. Usually, type 4 LSA given routes are seen as E. Now it will appear as N, not so stubby area, which means you are learning type 7. So you are learning it as type 7. LSA type 7. Instead of 5, you learn as type 7. So the reason why we use not so stub area is I want to use local autonomous system, local ASBR, local autonomous system border router given root, instead of using the ASBR which is on some other area. I think I no need to give more explanation. It will take a lot of time. We have already covered this. Kindly go through the previous class video. With the demo, we have explained this. I have explained this. Next. The other two stub we have is total stub. What is total stub? What is total? Everything. Everything stop. What all comes from other area? What all comes from other area? From other area, you get type 3, type 4, type 5. Everything is denied. That's what called as total stub. Not just 4 and 5, everything. Now, the other one Cisco has is total not so stub area. So same thing applies here. All these things are denied, but still this is allowed. So depending on what you want, you can pick one of the stub type. 4 types of stub we have in Cisco. Stub, not so stub, and both this total or Cisco's. Total stub and total not so stub. So if anyone has got any question on this 4 stub types, this is also called as OSPF network types, stub type, stub network types, network types. If you have any question, you may ask now. You were, have you been, you were in the class, previous class, lab, demo class? Kindly go through that video and then come with question, please. Huh? Kindly go through the video once and then bring the question in the next class. Of course, it should be there. Let me check. Anyone else got any question on the stub? Okay. Now, the next topic in OSPF that we are going to see is authentication. OSPF authentication. Kindly mute. Someone has not mute your mic. If you want to talk, you can unmute and talk. Oh, kindly mute your mic. You got the video already. You got the link. Thank you. So, authentication is important. You know, any authentication, not only OSPF authentication, any authentication, there is one basic thing you have to do before you enable expect authentication. What is that? Clock. The time needs to sync. The time need to match. Now you may think like, what if I have a router in India, a router in Sydney, via a tunnel, I'm forming adjacency OSPF. Now, right now, the time in India is 9:54 a.m. In Sydney, it is 3:24 p.m. Now, you may think like, oh, what? How can I have authentication now? They're not syncing in. The time is not in sync. It's different time zone. Different time zone. How will I be having this authentication feature? We have universal time. Okay, you need to follow the universal time on both router. When you follow the UTC time, then you have no problem. Okay, so any authentication, not only OSPF, it may be AAA authentication using Radius or TechX, or it can be a simple MD5, or it can be SHA, or it can be a plain text authentication, whatsoever. The clock should be in sync. The time should be same on either side. Okay, so you may have your own clock, but still the UTC is configured. All right, so make sure that is in sync. The time difference by UTC you mentioned, and router will take care of it. Now let us get into OSPF authentication. Open shortest path first. OSPF authentication is of three types. Yeah, I have to mention as three type, though it is two type. The reason is, even if you don't have authentication, that is considered as a type. We call it as null authentication. Even if you don't have an authentication, it is considered as null authentication. Null authentication. So we got type 0. Type 0 is one authentication, which is by default null authentication. When I capture and show you a packet, you will see that type 0. So you need to consider this as one type. The other one is clear text. The other one is MD5. So we got various types, three types: null, clear text, and MD5. Both the side you should have same type and same password. Sometimes password is same, but the type is not same on either side. So make sure you match both type as well as password. If one is mismatching, they are not going to form neighbor. Even if password is same, if the type is mismatched, then they are not going to form neighbor. Null authentication is no password, nothing, default. So if one side I enable authentication type 1 and password as Cisco123, and other side is type 0, they won't form neighbor. Two things mismatching here, both type and password. All right, let's quickly do this lab and I'll show you this. Okay, so let me use a notepad to finish the configuration. We are going to see authentication. First, we'll enable OSPF without any authentication on it. As I said earlier, the time should match on all the routers. Let me show you that. Show clock. clock. Here the clock is same, UTC 4 o'clock, 4:33. I'm okay with that. March 31, it is showing UTC time, Universal Time Clock. I'm happy. And it should be the same time on every device. Show clock. Say again 4:33 here. 4:33, 4 show clock. The reason is when it generates a hash value, it will use that time. When MD5 algorithm hashes the password, it uses even the session. Okay, now let me use a notepad to put the basic configuration on each router interface, loopback 0, IP address 1111.25255 interface. Interface F00. IP address will be 10.123.0.1. And then I would like to enable OSPF IP OSPF 1 area 0. And also I'd like to set priority so that this would be a DR IP OSPF priority 254 and the write to memory. Select all copy. I put this on router 1. It's over. Now, show IP OSPF interface brief. There are two interfaces running OSPF, and then show IP OSPF interface F00. You can see here the priority that I set on this interface is 254. And it is trying to form neighbor. The state is waiting because no other router is configured. It is in waiting state. No DR, BDR so far. But after some time, it will declare itself as DR. Let me show you again now. Maybe now it might have, see, it has taken the position of DR because the others are not available for competition. Okay, R1 is over. Let's go to R2. R2, I want this to be a BDR, so I'll set priority as 200. Now let's move on to the router's configuration. And I do not want anything. I just want to leave the default priority, which is 1. Select all, copy, put this on router 3. So router 1 is going to be a DR, router 2 is going to be BDR, and that I want to see it in R3. Even though R3 has got a bigger router ID, that doesn't matter. Priority is the priority. Priority is preferred first. So as a result, you will see show IP OSPF neighbor. You will see router 1 as a DR because of the highest priority, router 2 as a BDR because that's the second highest priority. But the router ID of router 3 is higher. Again, as I said, the first preference is given for the priority. So if you go and check with R1, it will have full relationship with R2, but two-way relationship with R3. Show IP OSPF neighbor. You can see two-way relationship. Sorry, yeah, that's what. What? Okay, this is a DR. DR will have full relationship with everyone. Yeah. So if I have another DR other, then they will have two-way relationship. Listen carefully. DR and BDR will have full relationship with DR other. Only between two DR others you will have two-way. Now I can see here it's BDR, it's DR other because of the priority, not because of the router ID. Router ID is second. First, the priority. The router with the higher priority is the DR. Now, we got the adjacency, we got neighborship. So if I'll go and check in the routing table of R3, I should see all the routes. Show IP route OSPF. I can see the routes of other two router. Now I would like to capture a hello packet and show you debug IP OSPF event. And now you're going to see hello packet every 10 seconds. And now this hello packet, if you see, this is coming from 10.0.0.2. And you're also sending a hello packet to a multicast address. Okay, now let me stop this and I want to show you again another packet. Debug IP OSPF packet. Now this will show you something more input, more light on the hello packets. Okay, now what you see is it says authentication type is 0. See, that's why we call this one as one of the type. Authentication type is 0. And this is an OSPF hello packet. How do I know? Because the type is 1. See, there are 5 different types of packets in messages in OSPF. 5 type of messages in OSPF. What they are? Type 1 is hello, which you see here, T1. And then type 2 is DBD, database description. Type 3 is LSR, link state request. Type 4 is link state update. Type 5 is link state acknowledgement. These numbers are not simply sequence numbers. This is how they are identified. If you see OSPF type 4, it means LSU, link state update. Alright, if you want to see that, I can show you clear IP OSPF process. Yes. Now you'll see updates also going. See type 4, type 5. Do you see that? T4, T5. Yeah. So we are saying that the type, authentication type, 0, and there is no authentication. I also want to show this in another place. Where? The Wireshark. I'm going to sniff the packet here. Right, so you have a hello packet coming from router 2, coming from router 3, and also coming from router 3, 2, 1. Okay, so let's pick one by one. I'm on router 2. When I click on this, I can see that the header has got hello packet 1. You see the bracket 1, type 1. If you go down here, it also says authentication type is null, type 0 authentication. And there is no data in it, no password, because it's type 0. But in the hello packet, this is shared, and this must match with the neighbor. This must match with the neighbor. It's important. Yeah, in OSPF header, this must match. Okay. This, if this don't match, the neighborship won't come up. Yeah. So if you check the other router, first router, third router, let me show you. There will same thing, null 0000. Take any router, second router, same thing, first router, same thing, and they must match. Otherwise, the neighborship won't come. So what I'm going to do is I'm going to go to router 1 and put the password. And as soon as I put the password, you'll see the neighborship will break. Because in the hello packet, the authentication field is different. Let's go. Router 1. Right now, show IP OSPF. Neighbor, I have two neighbor. But now, as soon as I put the IP OSPF authentication type, authentication key, authentication. Okay, just give the password. Just put enter, hit enter. When you say hit enter, it means plain text authentication. You have enabled plain text authentication. Now, I have not even given password, okay? I'm going to take you here. On R1, you see, simple password enabled. Earlier, see, if you check router 3, it says null. But if you check R1, it is saying simple password type enabled. In R3, null. In R2, null. In R1, simple password. The type is mismatching. Even though there is no password, the type is mismatching. As a result, router 1 already lost the neighbor. You see, router 1 neighborship is gone. Router 1 neighborship is gone. It is expired in R3. Because R3 and R2 says, hey, R1 is talking something which I don't understand. So R1 says, I have a plain text, simple password authentication. The other two don't agree. So the other two got removed. Other two are not ready to accept this guy's hello packet. I have not even put password. Now let's put the password. IP OSPF authentication key. See, when I put simply authentication, there is blank authentication data. There is no data in it. I'm going to put the key now. I'm going to say key as John. That's the password. Now if you see here, earlier it was blank, but now when I click router 1, I should see the password. Okay, see John. This is the danger of simple password. Someone can sniff the packet and see the password. So we should try to have an encrypted authentication data for which you need to enable MD5 authentication. Now I'm not going to get into MD5 authentication now. Let us first check this. The workers are calling. Test this. So R1, if you click on R1's packet, you will always see John, and the R3 null. What about R2? R2 also null. Only R1 has got the simple password enabled and John. As a result, R1 got discarded from the other two neighbors. Show IP OSPF neighbor, nothing. So let us go to the other two router. Now if you go to router 2, router 2 has got very good relationship with router 3. Show IP OSPF neighbor, it has got neighborship. Because they don't have password. These two are sailing in the same boat. They don't have any password. They both have null. Let's put here interface F00 IP OSPF authentication. If you don't say what type of authentication, then which means it's type 1. And then when I say now IP OSPF authentication -key John, you will find neighborship coming up between these two routers. Look at this. Router 1 loading to full, you see? But you will lose neighbor with R2. R2 will lose its neighbor. Between R2 and R3, something is going on. R3 is expired already. So if you go now, click on R1's hello packet, it is John. R2's hello packet, it is John. But R3 hello packet is null. Now let's go and try to do debug and see the difference. Debug IP OSPF packet. And here you will see authentication type 1. Earlier when I showed you, it was type 0. Now it is authentication type 1, which is plain text, which is simple password. Even in Wireshark, it is more clear. It says bracket 1. But in router 3, if you see, it is 0. The bracket is 0. Null authentication is 0. Simple password is 1. This is the password. Now let me go to router 3 and enable authentication. Because router 3 got discarded from the other two. Show IP OSPF neighbor. No neighbor. Interface F0/0 IP OSPF authentication. IP OSPF authentication key John. And now you see the updates are going in the background between router 2, router 1 and router 3, and neighborship has come up. Now all three are neighbor and I should see root now. Show IP route OSPF routes available. Show IP OSPF neighbor and I see neighbors. Alright, what is next? I'm going to change the password in one of the router, not the type. Let the type be same. On router 3, I'm going to say interface F00 IP OSPF authentication key. I'm going to change the case JOHN. The case must match. The passwords are case sensitive, we all know that. So as a result, I lose the neighborship now. You see, router 1 has got small j. Router 2, okay, here. Router 3 has got capital John. Router 2 has got small, router 1 has got small, but router 3 has got capital. Router 3 has got capital. As a result, the password is not matching, so the neighbor has gone down. If you want, you can debug and see why it has gone down. Debug IP OSPF events. It says mismatch authentication key. How friendly it is, you see. It clearly says the authentication key is the problem, not authentication type. Authentication key is the problem. So when I put the key right, and now I'll gain the neighborship. The neighborship has come up, loading to full. So it's very easy to troubleshoot why the problem. It was very clearly showing it's the key. And now if I click on R3, it's small John again. Okay, now let us go and change the authentication type. I'll go to router 1 and enable MD5. The password is same, John, but on router 1, interface F00, IP OSPF authentication message digest. Boom. Now you will see neighbor going down. Meanwhile, I'll take you to router 1. You see router 1, router 2 has got, router 1 has got message digest. Look at this. Authentication type is 2, cryptography. The key ID is 0, the key length is 16, the key sequence number is this, and this is the key. Can you believe this? John is seen as F, B, C, boop, 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 something like this. So R1 says I have authentication type 2, cryptography, whereas R2 says we have type 1, simple John. Router 3 also says we have the same, but only router 1 says I have cryptography. I have MD5, I have message digest. So what? So you got lost the neighbor. Now, how do you check these things, whether the problem is with key or the key type in debug? Debug IP OSPF even, same command, even. Earlier when I was showing you this, it was showing authentication key mismatch, but this time it very clearly says that authentication type is what the mismatch. What it says, we are using type 2. Who is saying? Router 1 is saying I'm using type 2, but the others are giving type 1. How straightforward. Yeah. So let's go to now the route 2 routers and make it a script 2. Simple. Interface of 0/0 IP OSPF authentication message register. Likewise on router 3 IP boom. So you're going to find neighbor with everyone. Okay, router 1 is a neighbor. Show IP OSPF database, show IP OSPF neighbor. You have neighbor with both. And when you check the Wireshark, you can see on R1 it is cryptography. On R2 also it is cryptography. On R3 also it is same cryptography. Right, MD5 is more secure because even someone using Wireshark will not be able to know the password. That's all about authentication in OSPF. So we have seen various things about OSPF to an advent. And now we're going to start from the introduction. OSPF protocol introduction. It's a link state routing protocol, as we all know. Yes, yes, yes. Now they built the routing table with the help of link state advertisement that comes from every other OSPF router. You see, if you take EIGRP and RIP, they build the routing table based on the route update given by the other router. Meaning, what does it mean, route update? The other routers will give the best route from the routing table. That is how they build the route. By learning the other routers routing table, meaning by learning the best route from the other routers, this router will come to a conclusion about its best routes to the destination. Whereas link state routing protocols, they don't learn any best routes from the others. They learn all possible link states, links and their status. With the help of that, it builds a database called LSDB or link state database, on top of which the SPF algorithm will run and find the shortest path for every destination and puts that route in the routing table. So if you see here, there is a big difference between other protocol and this protocol. The distance vector protocol, they don't advertise all the link status. They advertise only those best routes from the routing table. They don't advertise all routes, they advertise only the best routes from the routing table. So the neighbor who receives that will not be learning about the topology, will know only the best routes of the neighbor, using which the receiving router now needs to find a path. So the information is not complete. When we learn others' routing table, the information that we learn is not going to be complete. Whereas these link state protocols, they advertise every link and their status When I say link and the status, it talks about the bandwidth of the link, type of the link, network on the link, cost on the means metric on the link, all this, what area it belong to which router ID this link belong to, everything. That makes this routers to learn the complete topology. Using that topology, which is called link state database, the shortest path algorithm, SPF algorithm, can find the accurate path for each destination, and that accurate path is installed into the routing table. So this is link state routing protocols way of learning route, best way of learning route. ISIS and OSPF are two protocols that are considered as link state routing protocol. Now this routing protocol also maintains three tables.